Hey, hello, everyone. We're going to go ahead and get started with our webinar. We're thrilled to be joined by Dr. Angela McIver, who is our founder and CEO of Trapezium Math. Angela is a longtime math educator, curriculum designer, and researcher who has dedicated her career to helping students build confidence and joy in mathematics. She's known for bridging the gap between research and practice, giving educators practical strategies rooted in evidence. Today, we'll be hearing about part two of Angela's webinar series, From Evidence to Practice, which will be focusing on the foundation of math, which Angela will talk about, which is counting, and what the science really tells us about how to strengthen counting in classrooms. So with that being said, I will pass it off to Angela to get us started.
Thank you. Thank you so much. I'm so excited. These webinars are quick. They're 30 minutes, start to finish. And our focus this week is picking up on the introduction last week of our framework. And so today we are going to learn why counting is such a critical skill in building math foundations. And then we're going to talk about what those counting expectations are and should be by grade level and how they are developed and assessed in the classroom. We're also going to look at some students and see what does counting fluency look like. We have video of students who are demonstrating counting fluency, so you have an understanding of what that looks like. And then finally, we're going to talk about how this is treated in the standards, because the webinar series that we started is intended to shift the way we think about how students learn math and think about it in the same way science of reading is pushing us to talk about the parts of the whole in how students learn how to read. And so we're going to be looking at, do the standards need something more? Do they need a framework that can help support the development of these strong math foundations? So last week I introduced the framework. So we're going to start from there. What does this framework look like? And how does it correlate with science of reading framework? When I started researching how kids learn math, I started because I was a middle school math teacher who left teaching math to study how kids learn math because we had so many students coming into sixth, seventh, and eighth grade without the foundational skills necessary to be successful in pre-algebra, algebra, and beyond. And I wanted to find out what was going on. But one of the things that I realized for elementary school teachers is that they lacked a framework similar to that in science of reading that can help figure out where students are at each place on this continuum. So all of the parts that make up the foundation that's necessary to be able to learn math are very similar to all the parts that make up the foundation necessary to read. And so there is a saying in schools that from K to 3, you learn to read, and from fourth grade on, you read to learn. And a similar thing is the same in elementary schools, but we don't have a framework, and that's why we see greater than 60% of students leaving elementary school not prepared for middle school and high school math. So let's talk about that framework very quickly. So we have a framework that can be remembered easily by the acronym CRAFT. And here is how it aligns with science of reading frameworks. Counting is the same as phonemic awareness and phonics. So phonemic awareness and phonics is all of the foundation that you need to know before you learn the words. Before you learn the words, you need to learn the letters, and you need to learn that letters have sounds, and you need to learn that when you put them together, you have phonemes, and those put together make words. Well, there is a similar corollary in math, and we're going to talk about that today, which is counting. That's before the operations, before the conceptual understanding, before any of that. You need to learn about numbers. Students need to learn numbers. And so that is the first part of the framework. The second is reasoning, which is the same as comprehension in science of reading. The third is automaticity, which is going to be our workshop next week. Automaticity and mental math fluency. And that is that's see it, know it. Students just have to have this fully automatic. They don't have to count on their fingers. They're not doing counting in their head. They just see it and they know it. It's the same as orthographic mapping in reading and sight word recognition. So, and then fluency has many parts. We're going to next week talk about specifically mental math fluency, but fluency is just your ability to take this automaticity, see it, know it, and then do something with it. That's the same as in reading, you take your sight word recognition and your orthographic mapping, meaning you can apply the rules to the way words are created, and you can read a word on sight beyond your sight word recognition. But fluency is taking that understanding and doing something with it. And so in math, there's two parts of that, automaticity and mental math fluency. And finally, we have a piece in math that is tenacity. And that is from a very young age, starting in kindergarten. You can teach students to approach math problems with this eagerness to grapple with it. And that means giving students harder problems than what they currently are seeing in elementary schools. So we will be talking about all of that throughout the series, but today the focus is on counting. So let's get started. So why is counting critical as a foundation for learning math? When I first got my PhD, I was studying older students with weak math foundations. And one of the ways that I studied them was just to sit them down, put a camera on them, and ask them lots of questions about math and have them tell me what they were thinking. And it fundamentally changed the way I thought about how we taught math. But I never asked them counting questions. It wasn't until I was working in a high school in Kentucky in a remedial math class and I was sitting in the back observing it, and a student was called to the front of the class to answer a fairly simple elementary math problem to share their thinking. And they couldn't. They didn't know where to start. They didn't know how to approach the problem. And I thought, that's just a counting problem. I mean, it was a problem that students could use an algorithm to solve, but really at the base of it was a counting problem. And it occurred to me that I had never asked students to count for me. So while I was at the school, I usually get permission to sit and interview students and videotape them. I started asking kids just to count for me, and I would just give them random numbers. And I was blown away at how little fluency students had in counting. And the one the one student that really blew my mind was I asked her to start at 27 and count up by tens. And she could not do it. And she got very flustered in trying to like count by tens. And then she finally said, I don't do tens. Like I don't count by tens. I don't do it. And so I came back home and met with a very good friend of mine. Her name is Dr. Ellen Clay. She is a PhD in mathematics. I don't have a PhD in mathematics. I study how children learn math, but I rely on mathematicians to help me make sense of what's going on with students, what's going on with their learning, what is the math that we need them to do. And I took her out to coffee and I said, I think I have figured out the problem. The problem is counting. And she said to me, Angela, if I could develop an elementary math curriculum, it would just be counting. I can teach everything in the elementary math curriculum via counting. So something about Dr. Clay is she's a former college professor who quit teaching at the college level because she was so unhappy with the caliber of students that were coming to and she was thinking, what's going on in K-12? And she went back to the University of Pennsylvania, which is where I met her, and started doing work with schools around building strong math foundations. And that's how we became friends, and that's how we started collaborating. So after this coffee, I said, can I interview you? Can you talk to me and share why counting is so important? So I'm going to play this interview for her. I'm going to play it in its entirety. Whenever I do professional developments, I play parts of it, but today I'm going to do it in its entirety because she talks about how important counting is from kindergarten all the way through fifth grade. So here we go.
If I had to pick some topics, honestly, I would count every day. I would have counting competitions, counting activities. I just think, and then I would train people what counting does for you. That counting is addition, subtraction, multiplication, and division. People would need to know it. I asked teachers, and teachers count with their kids, and then they come back and they said, okay, we did it, now what? Okay, so they don't get that counting gets you all of addition and all of subtraction, as long as you think of subtraction as subtracting as taking away. It does all of multiplication that you can do with repeated addition, and it does all of division if you can do it by repeated subtraction. Okay, so I think I would make sure kids knew what the operations were. So addition, subtraction, multiplication, division. And by multiplication, I would insist that kids knew it was repeated addition and that it was this, what I call the area model, an area when it's contiguous, okay? I would want to make sure that division they knew as both repeated subtraction and as a factor of as the length of an area, you know, as a factor of product. And then I wouldn't separate fractions from whole numbers as much as people do. I'd be counting by fractions. I would be adding whole numbers of fractions from early on. I would count backwards until kids realized they needed to go past 0 so that they wouldn't be scared of integers when we started doing them. But kids should count by tens and count by hundreds and count by 110s and thousands and way before they start adding or subtracting, I think, because then it would just come naturally. So they ought to be able to count by every standard unit we use, ones, tens, hundreds, 12 inches, 1/100th, 1/10. I haven't mentioned decimals, but I just think of it in the place value. Fifths, 5 of them, 10 of them, 15 of them. And then at some point, someone ought to tell those kids what all those things have in common.
So the question is, what are the counting expectations by grade level? How do we develop them? How do we assess them? And we've spent the past 10 years working with students, working in our lab, working in classrooms, working with teachers to figure out what are the expectations that capture, 99% of students in this counting and these counting expectations. And we created this continuum that starts in kindergarten and ends, by the end of elementary school, and is demonstrable. It is, you can assess it, and you can pinpoint very quickly where is a student along this continuum in their developing this critical foundation. So here are the expectations. And just remember, counting is before the operations. And just like Ellen said, it's before students start learning addition and subtraction, multiplication and division. They should be counting by all of these different ways. And so by the end of first grade, we count kindergarten and first grade as one band. So it starts in kindergarten, but by the end of first grade, we expect students to be able to count in 30 seconds or less, forward and backwards, from 1s to 30 and back, their 5s to 100, 10s to 200. They should know their evens to 40 and back and their odds to 41 and back. By second grade, they need to show demonstration mastery of blue level counting skills, and we add on to that counting by 10 starting at any number. And then they start learning their multiples, 3 to 45 and back, 4 to 60, 6 to 90, 8 to 120. And this is 30 seconds or less. By the middle of third grade, not the end of third grade, by December of third grade, we want to capture the rest of the students in the rest of their multiples. Now, here's the thing. Students start in kindergarten and they can go as far as they want. We have many students who meet all of their counting skills by the end of kindergarten. Not many, but a good number. So many students with regular practice meet all of their counting skills by the end of second grade and are ready for learning their multiplication and division facts. But by the middle of third grade, we want them to finish their 7s, 9s, 11s, and 12s. The rest of their multiplication facts, they should have fluently 30 seconds forward and backwards. And finally, by fourth grade, students should be able to count to any number, from any number, by any number. We include doubling and halving numbers, finding quarters, finding fourths, finding fractions of numbers. They should be doing this fluently by the end of 4th grade. So what does that look like? So this is, we have teachers have students do these counting activities every day, and every day we're like it's 5 minutes. You take, 3 to 5 kids, they get up, they have 30 seconds, and you put a timer up there and then you count them. This is one of what our progress monitoring tool looks like. And I was in a classroom last week, so I captured a student who was practicing their threes. You see that they did it in less than 15 seconds. The reason we know 30 seconds captures 99% of all students is that when students get good at counting, they can do this in 15 seconds or less. And the record for students is 10 and a half seconds. That's the record so far. And kids, once they meet their are going to keep trying to get better in their fluency. So this is an example of a student who did they were doing their threes up to 45 and back. This is an example of a student who in 30 seconds was working on their sevens and was able to get all the way up to 105 and back down to 56. We do these activities out loud, orally in front of other students in the classroom, because not only does practice get students this fluency, but this regular hearing it over and over and over again. It's like hearing a song over and over again that you finally can just sing to it because you've heard it so much. So we ask teachers to do this as a whole class activity, and you do just a few kids every day, and kids become really excited to come in and do their skip counting. So what does counting fluency look like in young children? Like I said, this is an activity that we start in kindergarten. This is also an activity that parents can help kids do and love to help kids do. There was a study that showed that parents would rather talk to their kids about sex and drugs than help them with their math homework. So one of our goals is to give parents math homework that they love to do. And getting a timer and timing kids in counting is a lot of fun. And often the kids turn the tables on their parents and they make their parents practice as well. But we went through a process of asking parents to send us videos of their kids practicing their counting and got permission to be able to share them. So I'm going to share a video of a kindergartner. Now, this kindergarten student, took counting and just went with it. And by the end of kindergarten had mastered all of their skip counting goals and had also mastered their prime numbers, their square numbers, and their cube numbers. So this is a kindergarten student doing counting by nines.
Go.
9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 99, 108, 117, 126, 135, 126, 117, 108, 99, 90, 81, 72, 63, 54, 45, 36, 27, 18, 90.
So I want to share the compilation since we had parents send in videos of their kids practicing counting. So this is what it looks like. And kids, you'll see some kids go really fast. Some kids are very deliberate and go slow, but that 30 seconds captures all of them. It's enough time for everyone. So here we go.
Go.
9, 18, 27, 36, 45, 54, 63, 72,
4, 8, 12, 16, 20, 24,
8, 16, 24, 32, 40, 48, 56.
6, 12, 18, 24, 30, 36,
7, 14, 21, 28, 35, 42, 49, 56,
2, 63, 54, 45,
132, 121, 110, 99,
28, 21, 14, 70.
27, 18, 90.
So skip counting is one of counting in general, and skip counting specifically is one of the easiest things to implement in an elementary math class block because it really literally is 5 minutes at the beginning of class, or some teachers do it during morning meeting, or they do counting as they're getting ready to go to lunch. It's something that's very easy to implement that has it probably has the greatest impact of everything that we talk about in that framework. fluency in counting probably has the greatest impact in helping students move along their grade level expectations and exceed them. So we know that counting is critical. We believe it is the most critical skill as a foundation builder for learning and understanding math. And the question is, okay, so what does this look like in the standards? How do the standards treat counting? So I looked at the Common Core standards, and then I took 2 states because every state took the Common Core standards and created their own. But I chose Texas and California for 2 reasons. Texas outright rejected the Common Core standards and said, we're creating our own. We don't want anything to do with those Common Core standards. We're going to develop our own. So we looked at those. And then California is kind of ground zero for math wars and has been incredibly vocal and active around what is taught in their schools. And so they too develop their own standards. So we're looking at the Common Core standards, and we're also looking at Texas and California, and where does counting show up? And does it demonstrate a need for a larger framework? So here we go. So in all 3, counting is really not discussed after grade 2. It's discussed conceptually. It's discussed as a potential as one of many strategies students can use, but it is not intentionally developed in students as a foundation for learning math. The Common Core standards doesn't even mention counting backwards at all. And that is the foundation for understanding subtraction. It's the foundation for understanding division. It's the foundation for understanding integers. And so it's not even mentioned in the Common Core standards. But let's go state by state. So Common Core standards, they talk about in kindergarten, grade 1, grade 2. And then after that, they're just like, hey, counting is one of many strategies we can use. But in Texas, I think of the 2 states did the best because 1, they include counting backwards, and they expand the amount of numbers that students can count by. But where they miss is that they stop after 2nd grade. But like, we don't need to count after that. And so, so there is this missing piece for this critical foundation for learning math, and can help explain why we've implemented standards. It could be one of the explanations for the implementation of standards hasn't moved the needle much. And I posit that it's because we're missing some big critical skills. So let's look at California. California just took the Common Core standards and put it in theirs for counting. So it's like they just follow Common Core. So we see that these the national standards and these 2 very large state standards that influence all the rest of the states don't think about counting as a critical foundational skill in the same way that we think about phonics and phonemic awareness as the essential starting point for being able to read. And we posit that counting is the essential starting point for being able to do math. We know, and we'll talk about more about that next week in our automaticity and mental math fluency piece, because we can't get to automaticity and mental math fluency until students have developed this fluency in counting first.